So what's it mean to be a SQL expert? I'm going to show you. Alright, so today we're going to be talking about expert level SQL. Now to start things off, we're going to be talking about unions, okay? Not necessarily because this is expert level material, but more so because we're going to build on this with the next lesson when we talk about recursive queries and such. So let's take a look at what I have up here. I have two tables here, store sales and ecom sales. Now let's take a look at these. So I'm going to run this. Okay. So now as you can see, these are two tables. One contains all the orders or sales from our stores. That's this query at the top. And the other contains all our orders from our online sales. So these are two separate tables. They're identical. As you can see, they have the same columns. But the only difference is one contains orders from our stores and one contains orders from our ecom channel. So now what if we needed to write a query and we needed to combine the results from both of these tables? What would we do? Would we join these tables? No, because we're not looking to join columns, right? These have identical columns. So joining these tables wouldn't make sense. What we want to do is we don't want to join columns, we want to join the rows. Okay, and that's where unions come into play. So let's take a look at an example. Let's see what this looks like. So let's say we wanted, let's say we'll do select sales order ID. Let's say we want order date, and let's say we want subtotal. Okay. Now let's say we want to, again, what we're trying to do is we want to merge the rows. We want this to be to show up in one query. So we're gonna select these three columns, and we're gonna say select from, and we'll select this from our store sales table. And now the keyword we're gonna use here is union all. Now there's two different things. There's a union, and then there's a union all. The difference is if you just use a regular union, if there are duplicate rows, it will eliminate those. If you include all here, it will include all rows, even if there are duplicates. In our case, it's not going to matter, but we'll stick with union all. So now I'm going to copy and paste this. Okay, and then we're going to add select. Oops. Okay, all right, so here's our final query. So we're going to say select these three fields from store sales, union all. We're going to select the same fields from our ecom sales table. So now let's run this and see what it looks like. And now you can see we have merged sales from our stores and our ecom. So we have all our rows here. But let's make this a little more interesting. Let's say since these are our store sales, we want to add a column here. And we'll say store. Let's say this is going to be our sales type. Right? And here we'll hard code ecom. Now let's run this. And there you have it. So now you can see we added a column here to differentiate our store records from our ecom records. Now, the one thing you want to keep in mind here is when you're using a union, you must have the same amount of fields, right? So let's say, let's see, salesperson ID, right? So now let's suppose that ecom did not have the column salesperson ID. Okay, but let's say we wanted that in here from our store side, right? So let's say that column was not available in ecom because there is no salesperson if they're online sales, right? So let's run that and see what happens. It should fail, and it'll fail. See, because we still have to preserve our grid, right? So there's got to be the same amount of columns. Okay, so all you do in that case is you would just add a blank, and now we can run this. And now you can see for our store records, we have salesperson ID, but for our ecom records, we have a blank, or in this case, a 0. So that is a union. And the reason why that's showing up as 0 is because of the data type of salesperson ID is a number. That's why. So in case you're wondering. Okay, so that's a union. Pretty straightforward, but that's if you want to combine rows. Remember, joins are for joining columns, bringing in columns from different tables. In this case, unions are for joining rows. All right, so now we're going to get into some really advanced SQL here. We're going to talk about recursion, right, and how we can show hierarchies and how we can in our query results. Okay, so I have a simple query up on the screen here. Let's run this and see what we get. Okay, now this is our employee table. So let's talk through this real quick to show you so you can understand what we're going to be trying to do here. Okay, so now this is a simple employee table, right? We have employee key, that's like our employee ID. And I'm just showing first, last name, and parent employee key. So what does that mean? That means that Guy Gilbert, his employee ID is 1. His parent employee key is 18. That means that his manager is employee 18 right here, who's Joe Brown. Now Joe Brown has a parent employee key of 23, which means that his manager is Peter Krebs. Okay? Now, Peter Krebs has a parent employee ID, parent employee key of 112. That's all the way down here. And that is Ken Sanchez, whose ultimate parent employee key is null because he is the CEO. So he is the boss. So there's no one above him. Okay, so that's the hierarchy we're going to be looking to show with our query here. So now let's go ahead and take a look at how we can do this. All right. So now, in order to show this, we're going to write what's called a recursive query. So let's go ahead and jump right in. So I'm going to come down here. I'm going to write with, we'll call this employee hierarchy as open parentheses, and now we're going to define our query. Now we're going to use our union, okay? So let's go ahead and write our first. So now, remember, there's only one boss, okay? And he doesn't have a parent employee key. It's going to be null. So we're going to have to write that separately. And that's where our union comes in. So let's go ahead and write what the query would look like for our CEO, okay? And I think this will make sense as we go. Okay, so let's go ahead. We're going to select employee key. We'll select first name, last name, and parent employee key. Okay, and then let's say because we're showing a hierarchy, let's say we also want to show the level, okay, what level they're on, like where they are on the tree. Okay, so boss is going to be hard-coded as a 1, okay, and that'll be as level. Okay, great. And we'll do from, and I'll just copy and paste this table here, and then that's where the parent employee key is null. Null. So this, I'll put a comment up here, is our boss, right? He is the CEO. Okay. So this is going to be a simple query that stands alone, returns 1 record, and this has to be done separately in our hierarchy because the parent employee key is null. So yeah, so now we're going to use our union that we just learned. So we're going to do union all, and now is where we're going to write our where we're going to start to build in our recursion. Okay, so now we're going to do select the same fields. I'll copy and paste that. Only instead of hard coding a 1, okay, it's going to be EH, which is this will be the alias we use later. Dot level. Okay, so we're going to reuse that field, okay, plus 1. We can get rid of this here. So for each time the query is called recursively, it's going to add a 1. It's going to add to that level, right? So, and then we're going to do from, obviously, dim employee. Okay, now's where we're going to join to ourselves. So we're going to do an inner join here. And we're going to use this table that we defined up here, right? So we're joining to ourselves now. Okay, this is where the magic happens, so to speak. And we're going to give that an alias of EH, employee hierarchy, that we used here, right? On, and let's alias this here. And this is just E, we'll call this. So on E dot employee key. Oh, I'm sorry. E H dot employee key equals E dot parent employee key. Great. Okay. And then, oh yeah, because we don't want to select our CEO because we already defined him up here, we'll do where, let's copy this, parent employee key is not null. Is not null. Okay. And now, let's close parentheses. So now this is like, think of this as like a little table here, okay, that we've created. Okay, a little hierarchy table we've created. So now outside these parentheses, we can reference this. So let's do select star from our employee hierarchy table defined here. Now, let's go ahead and, actually, you know what? Let's do this. E dot, I'm going to have to fully qualify these because we're joining to a table, to our hierarchy. Okay, great. And this as well. Okay, now we should be good. Let's go ahead and run this. Okay, now let's scroll through the results here and see what this looks like. So here's our CEO, the boss. And now, as you can see, his employee key is 112. So now next level down, these are level 2 employees. You can see that he is their boss, and they're level 2. And these are the employees, David Bradley, Terry Duffy, right? And then next level down is level 3 employees, Amy Alberts, right? And then next level down is level 4, right? So you get the idea. On the lowest level, looks like 5. So you can see what's happening here. Okay, now, but the cool thing about this is, let's say we only wanted to see level 2 employees. We can then add a where clause here, where level equals 2, right? And now we can run this again, and now all we have are level 2 employees. See? So pretty cool. All right, now let's take a step back and talk about this a little bit, and let's talk about what's happening. All right, so this first query where we defined our CEO, right? This is called our anchor query, okay? And this is where this level field gets materialized, right? And that's why we're able to call this in our recursive query down here. I should also point out that it's called the anchor query because that's really where this recursive process begins, right? So that first query, we're only selecting our CEO who has a parent employee key of 112, right? Then when that recursive query runs, it's going to join to itself. So it's going to join to all the IDs that have a parent ID of 112, okay? And that's going to return level 2. Then it's going to run again, and it's going to join those level 2s to their parent IDs, which will be the level 3s. So hopefully that makes sense, and you can see how this is recursive, because sometimes it's difficult to kind of wrap your brain around it by just looking at the query. Okay, now this inner join down here, like I said, is kind of where the magic happens, right? This is where we're actually joining to ourselves, okay, to do the recursion, to increment the level and keep track of what level these employees are at. So now let's, like I said, so we're then able to, outside of the parentheses, call this like it was a normal table. But keep in mind, this is like a temporary table. It only exists for the life of the query, okay? It's not written to your database or anything like that, okay? Just think of it like a temporary table, okay? Right, and we could do order by level, okay, and we can run that. Oops. Order by. And then we have our results down here, and you can see our lowest level is a level 5 employee. Okay, so now that's how to do hierarchical queries with SQL. All right, so now we're going to talk about partitioning. And this is something I personally find really cool. So the first thing I'm going to show you is an example that I think demonstrates what it is, how it works, and then I'm going to show you kind of a more real-world example of how it can be used. So let's jump right in. All right, so we're going to type a query here, and then I'll type the query and I'll kind of explain as I go. So we're going to select, okay, row number. This is a built-in SQL function that you can use to kind of create like sequential row numbers, right? Starting from 1, 2, 3, that kind of thing. Okay, so we're gonna do, but let's do from sales dot sales order header. Okay, and then we'll do, let's just filter down our results here, where sales person ID is not null, and date part, I'm just trying to filter down the results here so that it's easy to look at. That's all I'm doing. Order date equals 5. Okay, so we only want sales in May that actually were sold by a salesperson. Okay, so let's continue on with our select. So we're going to select row number, okay, over, that's the keyword, open parentheses, and we're going to say partition by salesperson ID, okay, then we're going to do order by order date, okay, and we're going to call this as row num. So let's run this. Oh, and you know what, let's select some other fields just so we can see what we're looking at. We'll do salesperson, obviously ID, and order date. Okay, since this is the field we're partitioning by, and this is the field we're sorting by. Oops. Okay, so we have partition by salesperson ID, order by order date, and we're just gonna keep an incremental count of the rows. So let's see what this does. I think this will highlight what's happening here. Let's run this. Okay, so let's take a look at these results. Now, here's our column, row num. Here's our salesperson ID and order date. So what's happening here? Well, you can see row number is incrementing. 1, the first row is 1, salesperson ID is 274, then 2, then 3, then 4, then it resets to 1 on a new salesperson ID, 275. So now let's scroll down to the next salesperson ID, and then you'll see here it reset again at salesperson ID 276. If we scroll down, and that went all the way up to 31 records, right? And then on the next salesperson ID, the count reset again and continue to increment. So this is how so you can see it's partitioning the database on salesperson ID. Now, the other thing I want to point out is our order by was also important because our order by dictated where the row number started counting, right? So in this case, the first order date per salesperson will get the first row num. So the earliest date. And as you can see, right, May 2012 got one, May 30, 2012 got 1, then a 2, and then May 1st, 2014 got the 3 and the 4, right? So that dictated which records will start the counting, right? We'll get the first row num, right? So both parts were important. The partitioning, obviously, and the order by were also important. So hopefully that should clearly show you what's going on. So now that you see how partitioning works with a simple example, let me show you an example of how you can use this, because I think that's really what'll tie this all together. Okay, so now we're gonna start a new query here, and this is gonna be more of a real-world example. So let's suppose that we want to know every day we want to know what % of our total orders for that day each order made up, right? So we want to know what % of the total are those orders for that, or is it a particular order for that day, right? So let's start the query here, and I think as we go and as I show you, it'll make more sense. So let's start select, and we're going to be using our store sales table. So sales.store sales. Okay, and let's say we're going to select our order date, sales order ID. So the sales order ID, this represents a particular order, right? And then we want the total due. First, let's take a look at this to show you what we're going to be doing here. Okay, so now you can see on May 31st, 2011, this order was for this amount, okay? But we want to know is of the total sales on May 31st, 2011, what percentage did this transaction make up, right? What % of the total? Now, in order to do that, we need two things. We need the total sales for May 31st, okay? And then we need to divide that by the total due, right? And that'll give us the percent of the total. Okay, so let's go ahead and do that. Now we're going to use partitioning. Okay, so let's add another column here. And we're going to call this, we need the sum of the total due, okay, over, and we're going to partition by order date, okay, and this is we're going to call this as total sales. That'll be our total. So now let's run this and see what we get. Okay, now, let's do this. Let's order by order date and sales order ID. Okay, let's rerun this. Okay, so now let's take a look at this. So now on May 31st, we have this sales order ID, this amount due, and then this is our total sales. So let's scroll down though. Let's look for a new date. Okay, here's a new date, July 1st, and as you can see, there's a different total sales. So our total sales of $551,023 is repeating for every date, right? For each date, so it's going to just repeat because that's the total sales for May 31st. And just to show you that it's changes on the next date, so on July 1st, this is the total sales. So if we were to add up all of these sales for July 1st, it would equal this total, $210,964. Okay, so now the last thing we need to do is we need to calculate the percent of total. So we will take our total due now, and we will divide by our sum of total due. And again, we just need to copy this partition portion, right? So all we're doing is using the same value here, value here, and we're just dividing by the total due, right? So total due divided by our total. Oops. And we'll call this as percent total. Oh, and then you know what? Let's add times 100 to make it a true percent. Okay, so now let's run this, and there we have it. So now here's our results. So on this day, May 31st, order ID 43659 is 4.2% of our total sales of 551,000. Okay? If we scroll down, you can see, so let's go down to this one. On July 1st, 2011, order ID 43843 was 17.5% of our total sales for that day of 210,964. And that amount was 37,106. So this is a good example, a good real-world example of how you can use partitioning in your SQL. So hopefully all this made sense. If you understand all this and the previous video I made, you should be on par with experts at SQL. All right, so that'll do it. Please don't forget to like, subscribe, and hit the bell. And also check out jamestechtips.com for more BI-related content. And thanks for watching.